Okay, so hello everyone. Am I audible? If I'm audible, please give a thumbs up in the chat section. Hello, if I'm audible, just give a thumbs up in the chat section. Okay, so since I'm audible, I wish everyone, I welcome you all to the beautiful session of Java Bootcamp Series 1. So, as we all know, the end sim of Java has been postponed. Yeah, it's both good and a bad news as well. Good because we got more time to revise with CodeChef Java series, and bad because we got extended. But don't worry, we all have got you covered. So in this session, we would be talking about Java fundamentals. Okay, so there we begin. Just give me a second. Okay, so is my screen visible to everyone? Okay, so here we are with the presentation. So in this session, we will be getting started with Java. Yeah, the symbol of Java is very cool, and it has a very story behind it. So yeah, therefore we begin with the introduction of Java. Yeah, the cute man and the smart man which you see on the left hand side is the James Gosling, the inventor of Java. Java was developed at Sun Microsystem Industry in the year 1995. It was originally called Oak, but later it was renamed Java. Why it was renamed Java and how it was renamed? Taking back you to the first slide, Java has a coffee symbol behind it. But why coffee? Why not any other thing? Because the inventors at the Java industry system, they were having a roundtable conference while sipping a cup of coffee. Yeah, you heard it right. So they decided to convert it from Oak to Java. How interesting is that? So in this session, we would be talking about the overview of Java, basically covering the fundamentals and also are getting ready, fully ready for our instance. First, will be the characteristics and features of Java. Second will be the compilation and execution process which happens in Java. JVM, JDK, and JRE. Third, fourth, JVM architecture. Fifth would be sandbox model. 6 would be a very surprise shootout time for all. So now we begin. Features of Java. What are the features of Java? It are Features of Java are basically simple, object oriented. Java is portable. Java is platform independent, secured, robust, architecture neutral, interpreted, high performance, multi threaded, distributed, and dynamic. So, what do we mean by simple? Features. Java is a very simple language. Java can be converted into a bytecode program which can be further executed on any programming system. It is object oriented. That means it can be converted. It has classes and functions while we perform the features of Java. It is portable. Yeah, you heard it right. Portable. Portable means that Java can be converted from one simple language to another and it is easy to carry out on any independent function. Platform independent. Java, in contrast with C and C++, doesn't require any platform, that is, it can be run on any platform dependent. We would be learning more about this in the upcoming slides. It is secured. Secured means that Java provides security features by the model security model through which Java is safe and can be used to further process of building application. Architecture neutral. Java has a simple and easy to understand architecture. It gives high performance. Java code can be written in easy few minutes and can be executed. It is multi-threaded. Multi-threaded means we can run simultaneously sub-programs on a system without disturbing the efficiency of the platform. It is distributed. Distributed as in there are features of class and objects which help Java make the purely, truly and object-oriented language. Now, the compilation and execution process. As shown in the diagram, what does it mean? When we are given two source codes. Now, my source code can be in the form of C++, C or Python, but I want to convert it into Java. Means running Java. I don't want to write it again and again in the Java file. So what will I do is I will provide the source code which would be sent to the code editor by the extension .java, and then that source code will be sent to the compiler. Now, the compiler will execute the source code. What if? Now, there would be two conditions. If the compiler sees that the source code has some errors, it would be sent reverted to the code editor. But if it doesn't have any errors, it would be compiled into the bytecode as shown here. Then this bytecode would be converted or would be sent to the Java virtual machine. What does it mean? Java virtual machine. Java virtual machine will be diving deep in our upcoming session. This is done by the .class extension. And after we have converted successfully our source code into the bytecode, we can execute our file. Java virtual machine. Yeah, you heard it right. I have been speaking about JVM for the past 2 minutes. What does JVM architecture means? JVM architecture means it is the architecture in basically what is happening at the back end. JVM. Now, I would like to dig deep as it is the basic and very important topic to understand both for the structure of Java as well as for exams. So now, JVM languages. The JVM language classes is first sent to the class loader. Class loader. Then, after the class loader has been executed, then it is sent to the JVM memory, where it is further divided into these five parts. Now that after JVM memory part has been executed, it is sent into the execution engine. After execution engine, it is sent to the native method interface and then native method libraries. I would like to dig deep now into the further process. Java memory area parts. But before that, I would like to take you to the class loader. Class loader is basically nothing but the class which we describe. And also before diving deep into the Java architecture, I would like to show you how we actually code so that we can later understand the working of the Java JVM architecture. So this is basically a normal program which we used to run. So now what is happening here? We see that this is the main code. Java.com package, second line public class main, public static void main, string arguments, and system.out in. What does it mean? I've written a set of instructions, but I'm not clear what it is written. There are many fonts, but I'm still using particular this. So this is written as public class package company package com dot company. What does it mean? What does this entire statement mean? Why we use package com dot company? It is simply because packages are used to related classes. Yes, you heard it right. Since Java is an object-oriented language, what it does is it groups all the functions and the classes together. Now, you see here there are the system and the other functions which are provided, and they have the common element, key element, that is the class, and the class name is main. So, it is the main has the two fundamentals which you should keep in mind before writing a Java program. The first is the main function. It is the entry point into the any application. When you want to start writing the Java program, we first write it into the main class. The main class clubs all the functions and the objects which we write in. And the main function should be the same. So whatever we name the class, it should be same as the text file which we are saving as. Yeah, here I have it is save our into Java, so here should also become as into Java. If it is the main, it should be main.java. Then only our program would be executed. Now, there are few other meanings. Public static void main. This statement, yeah, we have heard it many times in C and C++, but there's a slight difference here. This is the main method of a Java program, and every Java program must contain at least one main program. Or if it even doesn't provide it, it will default take it as the main method. System.println. This line. In C and C++, we write different execution statements to print out a statement. And then what we do is we in Java we use system.print in and the statement we want to print. What happened next is system.in is basically the output stream used in Java. It is basically used to print out the output. We can also use in system.in for giving the default or the variable input we want to. Anything passed in the strings could be used in the inverted commas is printed on as a plain text. So if I want to print hello world, so how would be printed? Here is my system of the class. Here I have described my class as a public class app and then my main program. And there I want to print the hello world. So after saving and executing, it would provide me as hello world. So yeah, this is how our file executed, and this is the basic structure of writing Java statements. Coming back to our JVM architecture. So yeah, so till now we saw that how Java is written and structured in a program, but this is the front end. But what happens actually at the back end? So to execute that one statement of line hello world, the JVM architecture provides class loader. That is class loader. The class loader is for basically nothing but the class which was defined there. In the program, we saw that it was nothing but the class main through which all the statements were interfaced. Now, jumping into the JVM memory. JVM memory is basically what happens where all the memory is stored. So, there are 5 ways in which our memory can be stored. In just a second. Here. The hierarchy of the class loader. So basically, the class loader is further divided into the Bootstrap class loader, the extensions, and the system class loader. When we provide two classes, that could be further up the hierarchy refers to in the down to top approach, custom one. So custom one is basically the class which is provided, and then it's further divided into the system class, extension class, and the Bootstrap class. What is Bootstrap class? A bootstrap class is a machine code which kickstarts operation when the JVM calls it. It is not a Java class. The bootstrap class is the parent class, but it doesn't, kick. It is not a pure Java class. It will always start your operation. So, what is the job of the bootstrap? What does it does? The bootstrap basically is the first class Java class loader which loads the classes from the location rt.jr. Bootstrap class loader does not have any parent class loader. It is the first program, is the first class, which will what will do is it will take the classes and it will locate it to the rt.jar, this location. After that, we have the second class, that is extension class loader. It is the child class of the bootstrap class loader, or we can say that it is the subclass of the class loader. So what does it does? It loads the extensions of the core Java classes from their respective JDK extension library. Its role is simple, that it does not do anything mainly. It extends, it stores and locates the extension of the Java classes which is provided into the library. It loads files from JRE, library extension directory, or any other directory pointed by the system property. It basically comes, as the word suggests, extension. It is the extension class loaders from different libraries and place it to the system property. System class loader. After bootstrap step loader and extension class loader, we have the last system class loader. It is the last step. So, what the system class loader does? An application class loader is also known as the system class loader. When we're writing an application, the basically it is written in the system class loader. It loads the application type classes found in the environment variable class path. So we have given a class path, and there whatever the environment is, or if not, the default environment will be taken as the class path, and we can search it by the cp command line option. The application class loader is the child class of the extension class loader. It is the application and the last class of the class loader. Then, after the class loader has been finished, the ARM code moves to the JVM memory. The JVM memory is further divided into 5 parts. First is the heap area, second is the method area, third is the JVM stack, native method stack, and PC registers. Sound familiar, right? Yeah, the names have been taken from the data structures we have been learning. So, the first is the heap area. What is a heap? Heap is a data structure which shares runtime data area and stores the actual object in the memory. What it does is it shares the runtime data. The data which we are executing on the side by side, it stores it and it is updated in the memory. It is also known as the backup option. This memory is allocated for all the classes and array. This memory is allocated for all the class instances and array. This heap can be used to allocate and give memory to all the class instances and array. Heap can be of fixed or dynamic size depending upon the system configuration. Now, what we want to give the space could be dynamic or be fixed depending upon our systems. So, when we talk about the heap area, there exists only one and only one heap running JVM process. So, the JVM process is simple, but for JVM process, we need to allocate the space to the variables like arrays, and that could be done with the help of heap. Moving on to the second one is the method area. It is a logical part of the heap area and is created on the virtual machine startup. So now heap is further divided into one. First is method area. So the first part is the logical part of the heap area is known as the method area, and it is created on the virtual machine startup like it's written here. This memory is allocated for class, structures, method data, and constructor field data, and also used for interfaces or special method used in class. Heap can be fixed or dynamic size depending upon the system configuration. Okay, so what does it mean is heap in method area, it is the space or the memory is allocated to the class structures. The class structures were represented in the code which was shown before, to the method data and the constructor field data. Constructors, they are basically the which help in the better execution of the program. And interfaces, again, as we said in the heap, it can be while providing the method area space, it could be dynamic or variable depending upon the size option. It can be fixed, size or expanded as required by the computation. It need not to be contagious. It can be size. Metadata ensures that there is no wastage of memory. JVM stacks. Yeah, stacks. Basically, stacks is the data structure which stores and operates on the two operations pop and push. Similarly, JVM has stacks. A stack is created at the same time when a thread is created and is used to store data and partial results which will need it while returning value for method and performing dynamic linking. So, a stack is created. When is a stack created basically? When a thread is created. But what is thread? A thread is nothing but a smallest unit of program, which would be covering further in our upcoming sessions. And JVM stacks is used to store that data and partial result, which will be needed while returning value for method and performing dynamic linking. When a thread is created, it is used to create the results and to store the results while performing linking. Stacks again can be fixed or dynamic size. It is chosen independently. The memory for stack need not to be contiguous. Native method stacks. What is native method stacks? In C, there also exist C stacks. Native method stacks are written in Java language. They are not written in Java language because they are firstly written in the C stacks. This memory is allocated for each thread when it's created. So when a thread is created, every thread has a space of its own which is provided by the native method stacks. And it can be fixed or dynamic nature. It can be of either. Again, fixed or dynamic nature. JVM architecture provides you to provide space either independently or independently, be it fixed or be it dynamic. PC registers, program counter registers. This is the last method in the Java memory system. Each JVM thread which carries out the task of a specific method has a program counter register associated with it. Every JVM thread which has a task allocated will have a specific method to program the counter register associated with. What it means when a thread is created, it is allocated a space or a memory. After that, each JVM thread will carry out a task along with PC register associated with it. The native method has a PC which stores the address of the available of JVM instruction, whereas the native method, the value of program counter is undefined. So what is the role of PC registers? We have created the thread, we have allocated the memory. Now we have to find where is a thread has been stored or where it is running. So PC register basically provides the address or stores the address of the thread. PC register is capable of storing the return address or a native pointer on some specific platform. PC register not only stores or identifies the address of the thread, but it is also capable of storing the return address or a native pointer on some specific program. So after completing the JVM architecture system, yeah, it is sent to the execution engine. In execution engine, our code is basically compiled into by interpreter, compile, or JDK, and then it is sent to the native method interface or the native method library. Moving on to JDK. JDK. As the name suggests, it sounds to be very cool. So does a Java development kit. Java development kit is a software developed kit to develop applications in Java. So Java is in JDK is basically a development kit. It has tools to basically develop applications in Java. It consists of Java virtual machine, library classes and development tools, along with the JRE. JDK is the first primary tool for code execution and has primary function of development. JDK is majorly used in development as it provides key functionalities to execute any program. JDK is a platform dependent. What does platform dependent means? That it would be requiring some other platform to work as well. JDK is a platform dependent, that is, for different platforms, different JDK require. We cannot use the same JDK at same other different platforms. As JDK is responsible for prime development, so it contains tools for developing, debugging, and monitoring Java application. Basically, JDK is responsible for prime development. Okay, so the prime development before when we write after the JVM has sorted out the structure of the code, JDK then sees the code and monitors it and provides tools for developing, debugging, and monitoring the Java application. Seeing that there is any error, executing that error, monitoring the Java application, that it provides a smooth environment. And JDK is basically nothing but a JRE plus a development tool. What is JRE? Let's check it out in the next slide. JRE, Java Runtime Environment. JVM stands Java Runtime Environment. It is the implementation of Java and is defined as software package that provides Java library. What does it mean? JRE. JRE, Java Runtime Environment. As the name suggests, it's provided an environment for the Java to be executed. JRE consists of JVM along with a set of libraries plus other files. JRE is majorly responsible for creating an environment for code execution. When we write a code, we know we have the set of tools which we can write from, which we can write the code from. We have the command, we have the fixed libraries and keys, but we don't know that the JRE basic, but we don't know where to write it. So basically, here the JRE comes for the help. JRE stands for Java Runtime Environment, which is responsible for creating environment for code execution. JRE is platform dependent. JRE does not need contain tools such as compiler, debugger, etc. That is the role of the JDK. Rather, it contains class libraries and other supporting files that JVM requires to run the program. So, what does JRE actually contain? It contains a set of libraries and other supporting files that would require in creating the runtime environment. JRE, Java Virtual Machines plus libraries to run the application, is known as our environment, Java Runtime Environment. So, till far we talked about that we have been learning about JDK, JVM, JVR, overview of the characteristic and features of Java, and everything in between. But how a code is run in the front end and at the back end, both have been done. Everything is fine. But what if something happened? What if my system crashed? What if when I'm going online, my code has been executed by some other file which can cause harm? So what does it do? I stated as you started that JVM has a main key feature that is nothing but Java provides security. And that is through sandbox model. What is a sandbox model? A sandbox is an isolated testing environment that enables users to perform and to run programs or open files without affecting the application system or platform on which they run. Basically, sandbox is also an isolated environment. What does it mean? It means that while I'm executing my own code, so it would be provided with all the development tool and kits. But when an outside source code tries to run in my environment, that source code has been provided with a different runtime environment, which is known as the sandbox, and which would be given only few unrestricted location and tools to work with. Software developers like us, we use sandboxes to test new programming code. Now, we all of us cheat in the exam. So to cheat the exam, the code may contain the virus. And now the software developers must use a sandbox to procure that. What is the procedure or how we do it? Sandboxes are usually by software developers to test new programming code. Also, a sandbox typically provides a tight control system set of resources for guest programs to run in, such as limited space on disk and memory. As I stated, when I was running my own code using Java instruction and JV and all the set tools provided by the JDK to write one specific code, but when we try to control the other source code, which is the guest code, the sandbox provide that with a very strict set of sources to run in, such as limited space on disk memory. In Java programming, the sandbox is a program area. It's like a program area, and it has some set of rules that programs need to follow when creating Java code. We cannot create or we cannot allow every source code to come in and to execute itself. So here comes the Java sandbox model. It is like an applet that is sent a part to a page. Since Java applet is sent automatically as part of the page and can be executed as soon as it arrives. What happens when an applet is used? Basically, applet is used in the web pages, and when it arrives directly on the web page, it can be executed and can be easily harm the system, either by accidentally or intentionally. You never know. The sandbox restriction provides strict limitations. Here comes the sandbox main role. It will provide with the strict limitation on which the system resource the applet can request or access. That applet should have been now would be restricted with limitation sources and programs. The programmer must write code that plays only within the sandbox. What does it mean when I say the sandbox should write only where the play? It means such like we as the children, we are provided with few limitations like not to go and here and there by our parents. Similarly, Java provides a play option in the applet, which is mean that it should be run within a small or a provided area of the code. So this was the sandbox model. Where is this whole system used? In the JDK or in the JVM? No. It is not used in the mainly uses function. The sandbox security model is used in the online judging system that is used in the programming contest. Yeah, you heard it right. So when we try to cheat on the lead code during our daily contest, that found our error. Why? Because the sandbox model restricts us to cheat. HTML5 has a sandbox attribute for use with iframes. The new launched HTML has a tag which uses sandbox as an attribute for security purpose. Now, we have a shootout time. You guys will be provided with a link at the end of these 4 sessions, and the one who answers all the correct questions will be given a very shootout to on our Instagram stories and can chance a win to goodies. So stay tuned, stay like, and any questions are most welcome in the chat section. Any questions are highly appreciated. So if anyone wants to ask for any questions or how to ace your exams, can ask. And I believe that with this bootcamp session, now everyone can become a topper in the Java NSEM exam, and everyone can score 100 on 100. So any questions would be highly appreciated. So, okay, so since I see no questions in the chat box, so anyone would have any sort of questions or queries can further feel free to reach out to me and ask. I will be happy to help them. Secondly, stay tuned for the shootout so that you can get a very good chance to win goodies or get a host or get a main specific name title on our CodeChef stories. So stay tuned for the further sessions. Thank you everyone and wish you very all the best for your Java exam.